In this video tutorial, we're going to be using Matlab R2017A to develop a test program that interacts with the MIRcat via the MIRcat SDK. Some requirements before we get started. We're assuming that you're running Windows 7 and above, that you've already installed the USB to serial driver, that you have the MinGW 64-bit C++ compiler, and that you have a valid Matlab license. Some other important notes. Matlab has some great documentation regarding converting C types to Matlab types on their website. We've included a link to this in the Getting Started guide. Matlab by default does not expose which variables are required for each function call. You must view the MIRcat SDK header file or the official SDK documentation to see what is required for each function call. Now let's get started. So let's configure the Matlab environment. The very first thing that we do here is we denote the location of the header file. We then use the default Matlab function load library, and we pass in the location of the MIRcat SDK DLL file, followed by the header file. Then we create an alias for this SDK, and we pass in the name MIRcat SDK. After that, we load the MIRcat SDK constants file, which is included in this example code. After that, we can get started. So now we're going to look at the basic call structure. And that's as follows. So ret is the return of any specific function. Calllib is the native Matlab function that allows you to call a function from a DLL and be able to use the function and get the return value in Matlab. So here we're going to check the API version, and the way that we do that is we call the function MIRcat SDK get API function. We pass in the name of the SDK that we're going to use, which is the MIRcat SDK, and we also pass in the parameters that are required for this function call, which in this case is a major, minor, and patch version as a pointer. So the way that we declare these three parameters is up above. We create an unsigned 16-bit integer, and then we convert it to a pointer using the Matlab function libpointer. And that's all it takes to get started. From there, the best practice is to determine whether the function call was successful or not. So what we do is we check to see if the return value is equal to MIRcat SDK return success. And this return value can be found in the MIRcat SDK constants.mat file. In the case that the function fails, the best practice is to unload the library and to throw an error. So now let's look at the process for starting a single tune scan. So the way that we're going to do this is we're going to first initialize the connection to the MIRcat. After that, we're going to check to see the number of installed QCLs. We are going to check for the interlock status, followed by checking for the key switch status. After that, we're going to begin the laser arming process. Now, the laser arming process takes 5 seconds. So what we do to wait is we have a while loop, and we essentially query to see whether the laser is armed yet. Once it's finally armed, we do something similar. We wait for the TECs to arrive at a safe operating temperature. And the structure for this is just the same. You have a while loop to check to see if the TEC is at a safe operating temperature. Once it is, we can start with the manual tuning. The way that you manually tune is you call the function MIRcat SDK tune to wavelength. You pass in a wavelength that you'd like to tune to, followed by the units, in this case microns. After checking that the command is successful, we check to see if the laser is tuning. Once the laser is tuned, we carry on. From there, we enable the laser emission. Then we check to see if the laser is emitting, and after that, we're all done. And at this point, we need to disable the manual tune mode. And the way that we do this is we call the function MIRcat SDK cancel manual tune mode. Now, if you forget to cancel the manual tune mode, it could lead to errors. So it's a very important step to remember. Now, that's all it takes to get started. And remember, at the very end, you have to disarm the laser with the MIRcat SDK disarm laser function, and you need to deinitialize the MIRcat SDK. So now we're going to go ahead and run it to see what it looks like. We see the API version. We initialize to the MIRcat. We see that the interlock is set, the key switch is set, the laser is armed. We wait to get to a safe operating temperature. And now this can take a few seconds. We start the single tune test. We tune to the wavelength, we enable the laser emission, we check if it's emitting, then we disable the manual tune mode, disarm the laser, and deinitialize the MIRcat. And that's it. You've written your first program that interacts with Matlab and the MIRcat. Thanks for watching.